Good morning or afternoon or how are you doing today? It's Mr. Greener with your Tuesday assignment with Distance Learning Day 5. Day 5 means we're kicking into transformations. As it goes for transformations in the coordinate plane, we are going to be dealing with three particular transformations that occur across the coordinate plane. Each day we're going to talk about each one. So today we're going to start on one, tomorrow another, and Thursday another. And then Friday, Study Island. We'll bring them all three together and you'll work on them that way. So let's get started talking about what the three are, and then we're going to focus on that first one. So we start off talking about translation. Translation refers to the movement of a point or shape on the coordinate plane, whether it's going right, left, up, or down. It is getting moved, it is getting translated. And when it translates, look at the shape, look at the example on the diagram here. It translates by, see that? Sliding. Watch again. It slides, whether it's sliding left or right, up or down. The shape keeps the same orientation and just slides to its new location, wherever that may be. And it may be a multiple. It could be up, oh, I'd actually go right. Go right or up or left or down or any combination thereof. It translates, it's going to slide to that location. Okay? The other one's a reflection. We're talking about reflection. It talks about looking at a line of access or a point where it becomes the reflected surface. So you have a point that it flips. Do you see it again? See how I'm doing this? It flips. I know magic, right? No, I'm not. Old remote. It flips and it becomes a different orientation. So now it's reversed. Think about when you're looking in a mirror. You're not looking at yourself straight on. You're looking at yourself turned. You're looking at a reflection. Same thing. So another one, rotation. That is the third option. When a shape is rotated, that means that it is getting turned. It is turning in some way across a point. So watch the shape. It's going to rotate. Fascinating, right? Let's do it again. Rotation. It's the funnest one to watch. Okay, at any rate, we're going to be talking about all three of these over the next 3 days. And today, we're kicking into translation. One thing you need to know, when you're translating a point or shape, it doesn't change the name of that point or shape. What it does, though, it gets notated as a move or a transformation with the help of an apostrophe. That's what all this big information that you're adding into your notes, everything on this packet needs to be in your notes this time. There's no extra. Really isn't, I promise. This is all information that needs to be in your notes, and there's a lot. And I don't apologize because this is needed, so make sure you're paying attention here. Let's kick into translation. Translation, we have two rules to worry about first, and that's going, of course, around or across the x-axis. So, starting off, we're going to talk about translating to the right. If we move a point or a shape to the right, however many spaces it needs to go, what's happening is then there's only one coordinate gets changed. If we're going left or right, what's getting changed? Think about the coordinate plane. That would be, of course, your x. So let's look at an example here. Point P is at 3, 2. That's where it starts. That's the original location. We want to translate it 9 units to the right. It's moving 9 to the right. It means we got to take our x, which is the first one in the ordered pair. X is 3. And we're going to move it 9 to the right, which means we're going to take that 3 and we're going to add 9 to it. Basic math? Yes. But it's still important to make sure you keep the system correct. So we add 9 to 3 and we get 12. So our translated point, P, went from 3, 2 to its new location, transformed, apostrophe, 12, 2. The Y doesn't change because we're only going left or right now. So if we're only moving in one direction, then only one of the coordinates will change. The other one will stay the same. Make sure you keep an eye on that and think about that. Okay, so that's moving to the right. Let's talk about going the other direction. We're going to go to the left now. We're going to the left. We're going to take that shape, and now we're still on the x-coordinate because we're just moving to the left. It means we're going away, right? So we're taking away. We're getting rid of it. Or we're subtracting. That's what I'm trying to get to here. Our point, again, P, is at 3, 2 still. This is where it all begins. This time we're going to move it 6 units to the left. We're going to move it 6 to the left. It's getting taken away. Again, I'm not going to screen out again. It takes too much time. Anyways, we're going to move 6 units to the left, which means we're going to take that x and we're going to do some subtraction. Basic math, yes, but changing because we have integers to deal with, negative numbers. We're in the coordinate plane, which means we have the negatives. to worry about. So we take a 3, we take 6 from it. But we can't do that, Mr. Greener. No, we can. We learned this in adding and subtracting of integers. So 6 from 3 leaves us with a -3. So our new point P, the transformed P, has now been relocated at -3, comma 2. So it went from a positive 3, 2 to a translated, by moving it 6 units to the left, -3, 2. P apostrophe for the transformation. I hope we're catching here. Okay, let's go the other way. Of course, we're talking coordinate plane. We don't just go left and right. We also go up and down. So let's talk about going up. Elevators, up. You're going up. That means that you're going up floors. You're increasing, right? So if we're going to take a translated figure and it's getting moved up by translation, that means it's sliding upwards. So if we're going up, we're adding to it, right? Let's go back to point P. I don't know why. It was easier to keep the same point, right? 3, 2 is now going to get moved 9 units up. If we're going 9 units up, that means our x is increasing those 9 steps. So that goes back to addition. When we're adding to it, we're going upward. We're going to take the 2 because we're talking about the y this time. We're going up and down. That's the y coordinate. So the 2 gets 9 added to it and becomes 11. Basic math here again. 2 plus 9 is 11. So we have translated point P and we have moved it upwards. So it's now relocated at 3. The x didn't change, just the y here. 3, comma, 11. Translated up. Okay. Now let's go the other direction, which of course is down. When we're down, we're decreasing. We're getting rid of, or we're lowering. So if that situation is going to happen, then we're going to take the y coordinate once again and decrease it because we're talking about moving down. So P, what a surprise, right? For the 4th time. 3, comma 2 is now getting moved 6 units downward. So we're only worried about the y coordinate, which is the 2 on this ordered pair. And we're going to move it 6 units down. So through subtraction again, integer, subtraction, we have a 2. We're taking 6 from it. That result's going to give us a -4 because of integers. So our new translated point becomes 3, -4. It is translated downward 6 units and it becomes 3, -4. Okay? We're catching it? Let's do a quick example here, and then I'm going to get into the assignment example and hopefully help you that way too. So, this triangle has been broken into 3 points. We have point A at -5, 4, point B at -2, 3, point C at -3, 1. We're translating this whole triangle 6 units to the right. We're going by 6, and it's an X, so it tells us we're moving to the right. Also, the instructions say moving to the right. So, we take our X point only, -5 on this one, and we're going to add 6 to it. So, -5 plus a positive 6 results in a positive 1. Integer addition with different signs tells us this. Remember that? Go back to your notes for remembering that one. So our new translated A apostrophe point becomes 1, comma 4. Okay? Let's go on. B. B's at -2, 3. It's also being moved to the right because it's part of this triangle. It's moving to the right 6 units. So the -2 also gets 6 positive steps added to it. And due to that integer addition, it becomes a positive 4. So our new translated point for B becomes B apostrophe 4, 3. And then the last point, of course, at -3, 1. Also add 6 to it. So that becomes positive 3, 1. For C apostrophe. Again, remember, this is all referring to the translation, the slide of a shape or a point. Now, our assignment today is going to be all about translating shapes. Okay, there's going to be 6 of them on this worksheet that you're going to have to do. And here's the example for number 1. Hopefully it stays on for us this time. I was having some issues before. I had to do this all over again. You don't need to know the story. Anyways, here's our point. We're translating it. Now, because we're going to make it a little more complex, we have 2 actions going on. We're moving up and we're moving left. That doesn't change the process. The process is still going to be the same. We're going to take each point and we're going to move it 2 times. We're going to move it 3 to the left and then 2 up. So, we have our 3 coordinates on our worksheet marked because it is a triangle. There are 3 important points to worry about. We don't have a name for them. You can give them a name if you want to. Let's say D, E, and F. I'm not saying you have to do that. You can name them whatever you want, or don't name them at all. Just remember what they are. So this one, D, is located at, there's no movement on the X, so that's a 0, -1, okay? So my D starts at 0, -1. We are modifying this thing through two translations, left and up. So let's touch on each one individually. Left, that's our X. So left 3 means it's going to go backwards. We're going to subtract 3. Well, if we have nothing to start with and we are subtracting 3 from it, then what's going to happen? Well, obviously, our translated apostrophe point, the X goes from a 0, and we're taking 3 from it. What's that going to leave us with? Obviously, a -3. But then we have to take the Y. The Y is moving 2 up. 2 up, starting at a -1. So if it's starting at a -1, it's got to go up 2. So we're going to say -1 and then up 2. So what's that going to give you? Again, integer addition, different signs, gives us a +1. So our first point that we're going to move or translate goes from 0, -1, this point here, and it becomes -3, +1. So that means we go -3, +1. And we have translated point D. Okay? Moving on, let's go to E. E starts at what? Our X is 1, and our Y is -4. Let's change the color on that one, just to make sure we keep this straight. So E begins where? I already said, +1, -4. +1, -4. Again, 3 left, 2 up. What is that going to do to that point? Well, I'm taking the X of 1, we're going to move it 3 to the left. So that becomes 1 -3. What happens when you have 1 and you take 3 from it? Obviously, with our new integer world, it's going to become a negative. So our modified or translated E apostrophe becomes 1 -3. Well, that's going to give us a -2. Right? 1 -3 becomes now -2 because of integer subtraction. Our Y starts at a -4, but we're taking it up 2 places. So it becomes a -4, add 2 to that. So again, integer addition of different signs. If we have a -4 and a +2, when they combine, they give us a +2. No, sorry, -2. Ooh, almost messed up on that one. See? Even Mr. Greener makes oops. -2, -2. So we have -4, add to it, becomes a -2. So our modified point E is now going to be at -2, -2. I'm going to jump back to the red just to keep the points in the same color. So we're going to go -2 and then -2 again. So that is now our translated point E apostrophe. Okay, our last one is point F. Now, I may jump off the screen here for a second because I'm going to go over here for that one. F is located at point 5 on the X. It is 1 down, so that's a -1. That's where it goes to start. Again, 2 movements, 3 left, 2 up. So we take the 3 left and to modify our X. Remember, X, comma, Y. I guess I should have wrote that at the very top, shouldn't I? Your ordered pair is always X, comma, Y. Never forget that, especially with coordinate plane stuff. At any rate, 5 is moving to the left 3 places, so that becomes a 5 -3. So our translated point F, apostrophe. Sorry, I don't know why I was that sing-songy. 5 -3 gives us 2. And then we take the Y coordinate. You can see I'm still here. We're taking the Y is at -1, we're going to add 2 to it. So it becomes a -1 plus 2. We're going 2 up. That means we're adding 2 to the point. So -1 and a +2 combine to give us a +1. So our new modified point for f becomes 2, +1. So again, going back to red, we're going to go 2, +1. Okay, now, where did we start? We started with this triangle here, DEF. Okay, we have modified all 3 points. Go ahead and mark that. All 3 points. So now, watch this. If you've done it correctly, then you end up, and of course I don't have a ruler that really makes this perfect, but our triangle has also moved with us. If you move all the points the same distance, the same amount, you end up with a translated shape. That's the whole concept here of translation with the transformation process. This is the way you're going to work the other 5 problems. Yes, there's math involved. I know. You'll be okay. You will. We're going to have our Google Meets today for 2nd, 4th, and 6th hour. If you have questions and you're my 1st and 3rd, obviously you can ask me through email, but my meetings are just for those 3 classes today. Hopefully keep an eye on this video, keep re-watching it. Hopefully it catch on. I mean, this is a process that's going to take a couple of times to do it. That's why you got 6 examples today to get you through this. You'll be all right. You'll get there. I have faith in you. I'll catch you tomorrow when we start talking about the next one, which is reflection. Okay? Transformation coordinate system. It's here. Keep moving. Get that homework taken care of. Ask questions. Please ask questions if you don't get it. Don't guess. Watch the video. I know it's all over 15 minutes long. I'm sorry. I know it's so long. But I've heard there's 7th grade teachers that have 40-minute videos. So you're welcome. Okay. All right. So get this. Get taken care of. I'll catch you here tomorrow for part 2 of transformations on the coordinate plane.